Okay, imagine this. Your body's immune system, your ultimate defense force, launches an all-out war against a cancer that's hiding somewhere inside you. Sounds great, right? That's what it's supposed to do. But what if, in the fog of that war, your immune system gets confused and starts attacking your own brain and nerves instead? Seriously, this isn't science fiction. It's a truly bizarre medical mystery called paraneoplastic syndrome. So let's dive into this strange case of biological friendly fire.
To really get our heads around this, we actually have to go way, way back. Our story starts in 1888, in a hospital in Berlin, where doctors were faced with a case that was so baffling, it would stump the medical world for nearly 100 years.
So there's this neurologist, Hermann Oppenheim, and he's treating a 54-year-old woman with all these severe neurological issues. She's confused, her mood is all over the place, she can barely speak. Well, she eventually passes away, and the autopsy reveals she had a massive stomach cancer. But here's the crazy part. Her brain was perfectly fine, not a single tumor, no visible damage whatsoever. And this is where Oppenheim makes this incredible leap of logic. He guesses that some kind of unknown toxic products from the cancer must be poisoning her brain from a distance. He was so ahead of his time, and he was absolutely right. It just took everyone else almost a century to prove it.
And the timeline to figure this out is just wild. Think about it. Oppenheim makes his guess in 1888. It's not until the 1960s that scientists get their first real clue. They start finding these weird, mysterious antibodies in the blood of patients with these symptoms. But even then, they didn't know what they were. It took another 2 decades, all the way until the 1980s, to finally pinpoint the first specific culprit, an antibody called anti-Hu. And that's when it all clicked. Oppenheim's toxic products weren't coming from the cancer at all. They were coming from the patient's own immune system.
And that brings us to the core idea of what we now call paraneoplastic neurologic syndromes, or PNS. Honestly, the best way to understand this is to think of it exactly like military-friendly fire.
So here's the absolute kicker. A tumor, as it grows all chaotically, can sometimes start making proteins that should only be found in your nervous system. Your immune system, doing its job, sees these proteins on the cancer cells and correctly goes, "Whoa, that's a threat," and launches a massive attack. But here's the tragedy. The immune system then sees those exact same proteins on your perfectly healthy nerve cells and attacks them too. It's just a devastating case of mistaken identity.
Okay, so how does this friendly fire, actually work? Well, it turns out the immune system has more than one trick up its sleeve. It has 2 main ways of carrying out this attack, and they're really different from each other.
And this diagram really breaks it down perfectly. You can think of it as one attack from the inside and one from the outside. One is this direct, hand-to-hand combat led by cells, and the other is more like a long-range missile strike using antibodies.
First up, let's talk about the direct assault. This is where these specialized killer immune cells, called cytotoxic T cells, literally invade the nervous system to hunt down and destroy their targets.
Right, so this is the ground war. The tumor basically trains these killer T cells. Then, these T cells act like a special forces unit, managing to get past the super secure blood-brain barrier. Once they're inside, they hunt down healthy neurons that have that same target protein, and they kill the cell from the inside out. It is a direct, brutal, and really effective attack.
Now, the second attack mode is way less direct, but it can be just as damaging. Instead of sending in troops, the immune system decides to launch a remote blockade using antibodies. This is the airstrike. This time, the tumor triggers the production of antibodies. You can think of them as these tiny, precision-guided missiles. They travel all through the bloodstream, find their targets on the surface of nerve cells, and just latch on. They don't actually kill the cell. Instead, they just block it from sending or receiving any signals. It's like cutting the communication lines for your entire nervous system, a total blackout.
So we get the what and we get the how. But this brings us to what is still a huge challenge for doctors today. How in the world do you diagnose something this tricky, especially when the real culprit, the cancer, is completely hidden?
Just let that sink in for a second. In about 2/3 of all these cases, the very first sign that a person has cancer is their nervous system going haywire. The neurological problems are the clue to a crime that nobody even knows has happened yet. So how do doctors even begin to connect those dots?
Well, they essentially become medical detectives. It's a 3-step hunt. First, they have to carefully map out the crime scene. What exactly is the neurological syndrome? What parts of the nervous system are being hit? Second, they look for fingerprints. They test the patient's blood and spinal fluid for those specific onconeural antibodies. And third, guided by those fingerprints, they launch an all-out search for the hidden tumor that started the whole mess.
And let me tell you, finding these antibodies is a huge deal.
When they find what are called high-risk antibodies, those are linked to a hidden cancer in over 70% of cases. Finding one is like discovering a giant flashing neon arrow pointing right at a tumor that has to be found, and fast.
To make it all official, doctors even use a scoring system. It's kind of like a diagnostic scorecard. They give out points based on the type of neurological symptoms, the risk level of any antibody they find, and of course, whether they've actually found a cancer yet. They add up the score, and that tells them if their diagnosis is possible, probable, or definite PNS. It basically tells them how hard they need to keep hunting for that tumor.
So, okay, the hunt is over, the diagnosis is made, now what? The final piece of this puzzle is the treatment. And the strategy is actually pretty logical when you think about everything we've just talked about. You have to fight the problem on two fronts. You've got to attack this from two different angles. First, you have to go after the trigger. That means you have to find and treat the cancer to stop it from winding up the immune system in the first place. But at the same time, you have to treat the attack itself. You use immunosuppressant drugs to basically tell the immune system to stand down, to call off the friendly fire and give the nervous system a break. You absolutely have to do both.
You know, when you step back and look at the whole picture, paraneoplastic syndromes are just this powerful and honestly humbling reminder of how unbelievably complex our bodies are. It's all about the immune system's delicate balancing act, and it shows how the very system built to protect us can, through one tragic case of mistaken identity, cause so much harm.
But I want to leave you with one last thought. This immune response in PNS is incredibly powerful, right? I mean, it's strong enough to damage the brain. So what if we could learn from it? What if we could figure out how to unleash that same intense anti-tumor attack, but learn how to aim it only at the cancer without any of the friendly fire? It's a pretty exciting question, and it might just hold the key to a whole new generation of therapies, turning this biological tragedy into a blueprint for victory.